So today I want to share with you a really fun activity. It's one of my favorites. It's called Rational Tangles, and it's one I've led with hundreds of middle school students, and they really love it. So I wanted to share this with you. This is a really good example of an activity that helps you to emphasize basic skills, computational skills, and also some vocabulary, but not by just telling them about the vocabulary or telling them about the skill or drilling on it, but rather posing a really interesting problem that happens to involve that skill and that vocabulary. So we're going to give this a go. Rational Tangles is basically a dance, but not elaborate dancing. We're just going to be moving around while holding ropes. So I need 4 volunteers to stand up. And I'm going to have you hold that, and you hold that, and then try to give him the other end of that one. There we go. Okay. So I'm going to sort of do this in a very short amount of time. The discussion that your students should have would come out of trying to figure out the puzzle, and you'll see what the puzzle is in a bit. But for right now, we're just learning the moves and the dance and how it works. So there are 2 moves. One is called do-si-do, and the other is turn them around. Now, whenever we do-si-do, whoever is standing right in that position will lift his or her arm up. This person will go under, and they will switch places. Okay? So that was do-si-do. Now, do-si-do, I'm just going to put a little note here, do-si-do. I'm going to call it, if I want to be fancy in an 8th grade, I'll do do-si-do equals x plus 1. If I were a little lower grade, I might say do-si-do is adding 1. Okay? So if you notice, the knot got, well, how tangled was it to begin with?
Untangled.
Untangled, so we're going to call that 0. And now we're at 0 plus 1 or 1. Okay, do-si-do again. So now you are in that position, so you lift your arm.
Oh.
Okay, and you go under, and that's do-si-do. And now we are at 2 because we added 1. So that's the first move. Now the other move, if we just kept doing that, we just, tangle around, but not that interesting. So the next move is called turn them around. So we did do-si-do. Now we're turning them around. Now turning them around, again, if I'm using my 8th grade notation, it's the negative reciprocal. So it flips whatever number we're at and takes the negative reciprocal. So we'll see how that works. So right now, we did 0. We went, I'm going to put a D up here because we did 1 do-si-do. We did another do-si-do and we were at 2. And now we're about to do a turn them around, which is going to make this number the negative reciprocal. And if you remember, we can make 2 into a fraction by doing 2 over 1. So what is the negative reciprocal of that?
Negative a half.
There we go.
Yeah.
So we're going to do it. Now, how do we do it? Turn them around. Basically, you go there, you go there, you go there, and you go there. So turn them around. Everyone goes one spot and stops in the position of the previous person. Fabulous. So now we're at negative 1/2. We just turned the rope around. So now what we're going to do is we're going to do-si-do. So go ahead. So excited. And now this one gets a little trickier. Negative 1/2, but we have to add 1. Now, depending on the level of your students, you may need to do some scratch work to support this. Negative 1/2, maybe plus 1 can be written as 2 halves. If you owe 1/2 and you get 2 halves, then you should have 1/2, which is great. And so now, let's go ahead and turn around. Now what does that do? Take 1/2 and I do the negative reciprocal. So what is that going to be? Gotta flip it and make it negative 2. There we go. Anyone want to guess what we're going to do next?
Do-si-do.
There we go. We are going to do-si-do. Go ahead. Do-si-do, which takes us to negative 1. Yep. And we're going to do-si-do again. Go ahead. Yep. I was thinking about who's lifting their arm. Yep. And we're back to 0. Now somehow we got back to 0 without undo-si-doing or unturning them around. Not sure how we did that. Some sort of amazing luck, I think. But now we're going to try this again. We're going to put a pretty, slightly more complicated fraction on here, and then it's going to be your job to untangle it.
Oh.
Ready? Okay. So I'm going to tell you how to tangle it in the first place. So we're going to start at 0. And I want you to go to do-si-do. So we're at
One.
1.
Yeah.
And do-si-do again. And so we're at,
Two. Two.
and do-si-do again.
Oh.
And now we're at,
Three. Three.
and now do-si-do again.
Oh, 4.
And we're at 4. And now turn them around. So what does that make?
Negative quarter.
Negative 1/4, right? Because remember there's an invisible 1 under there. So negative 1/4. And now go ahead and do-si-do. Now what's that?
Negative
Sure, negative 1/4
Four.
plus
Three.
4/4.
3/4.
Okay, so we're at 3/4. And one more do-si-do. 3/4 plus 1, really 4/4. So, but just leave it as an improper fraction.
Okay.
1 3/4.
Improper.
7/4.
We're going to leave it as the 7/4, but yeah, absolutely. So 7/4. This, for now, we're going to just take that as our complicated tangle. With the kids, we often get to like double digits here, but as a starter, I'm talking about it. As a starter, we're gonna do this one because it's our first attempt. It might be a good one to start with. So now what I'm going to do is I'm going to bag this tangle. Now you'll be able to see pieces of the tangle. However, because the bag is here, it's going to mess up your ability to tell how tangled or untangled the ropes are because it's going to accumulate around the bag. So you cannot tell how close you are to 0 by looking. From now on, you have to trust the math. You need to get back to 0. So what do you think you should do first? Okay, so we're at 7/4, and I've put the bag on here so you can't really tell whether more of your turning around or do-si-doing is helping it or hurting it because the bag's in the way. So what do you think you should do next to get back to 0?
So do we want to subtract?
I think we want to, turn it smaller.
Yeah.
So either add 1, do-si-do, or negative reciprocal of turnaround. Which one?
Turn it
Negative
around.
4/7.
Yeah,
Okay.
let's turn around.
And if we add 1, then we'll be at 3/7.
Yeah, so we're
So this,
Okay, so 3/7.
and then turn around again to get to the 7, to the negative 7/3. No.
Then we can add 3 to it and get down to 1/3.
Yeah,
Right.
so wait, what does that mean? So we have to turn around
So we're
here.
turning around.
Turn around here.
Yep.
Do we get smaller?
Negative.
2/3.
Now
you do-si-do
twice. Once.
Once.
Does that one take?
Once.
That'll take us down to negative 4.
Yeah, negative 4/3.
Yep.
And then
Do-si-do again.
And that takes us to?
Negative
Negative
1/3.
1/3.
Okay.
And then do again to get a
2/3, we positive 2/3.
positive 2/3. Or wait.
Or, because if we,
No.
we never, we have to do do-si-do again.
Yeah, do-si-do.
Okay. So 2/3.
Now we turn.
Turn negative
3
3
half.
over 2.
Yeah. And we add 1, so do-si-do.
Do-si-do.
That's negative 1/2.
Yeah.
And so if we do the reciprocal, will be at 2.
And then negative. Oh yeah, negative reciprocal would be at 2. Adding 1 would give us 1/2.
I think that's what we need to do, right? 1/2. So add
Yeah.
1, another
Yep.
do-si-do.
Do-si-do.
Okay, and so now we negative reciprocal and add. to
Yep.
third.
Turn.
Okay.
Negative 2.
Negative 2, and then
Do-si-do.
do-si-do.
Okay.
And
Do-si-do.
do-si-do again.
Okay.
Supposedly at 0.
Supposedly this is 0. Now let's check, because again, it's really hard to stay in step. And don't drop your ropes. Hold on tight. And you're going to do a little bit of jiggling, so hold on tight while other people power up. So, now what this is this is an example of a mathematical model. So if I were to try to call somebody, when it was tangled up at 7/4, if I were to try to call somebody in another room and describe to them how they need to tangle their ropes to get it the same as mine when it was at 7/4, it would be a very complicated thing to describe how they were tangled. But if they understand these moves, and I just tell them 7/4, I got to 7/4, they could figure it out. And it might be a little bit tricky, but they could get there. So 7/4 captures all the information that's in that tangle. So that's a really good example of how mathematical modeling works. We try to describe something complicated in a simple way with the numbers or with equations. And so this is a good example of that. And this kind of tangled up situation has applications. For example, if you think about the way DNA inside cells works, it's very long and stringy, and it's all kind of mixed up, churned up in the nucleus. Well, it gets tangled up. Well, there's something called a protein called topoisomerase, which actually goes in, cuts one strand apart, and rejoins it on the other side. But the question that nobody knows in the world right now is, how does the topoisomerase quote know that by moving one strand through another, that it improved, got it less tangled rather than more tangled? So this is an example of one kind of model that mathematicians and biologists use to try to get a feeling for tangles and how to understand them. So that's it.
Cool, great.
Thank you very much.
Thank
for
you.
your time.
Oh, that's a good one.